Hey there, you're about to listen to another episode of the PrimateCast. This one's with paleontologist Dr. Susumu Tomiya on the past, present, and future of biodiversity, bear dogs, and doing and communicating science.
Evolution,
communication,
cognition,
conservation,
behavior.
primatology,
Typically primates.
Become the monkey.
Hello everyone and welcome back for another installment of the PrimateCast. This is episode number 67 and it comes out on Friday, June 17th, 2022. I'm your host, Andrew McIntosh of Kyoto University's Wildlife Research Center, and in May this year, I was joined in the studio by my wonderful colleague, Dr. Susumu Tomiya, who I've worked with over the past 3+ years in the Center for International Collaboration and Advanced Studies in Primatology, or CICASP. Susumu and I have worked closely over that time, developing our capacity at Kyoto University to manage international programs and teach science communication to our grad students, and of course to encourage and promote their activities in various different ways. Susumu is an assistant professor now based in the Department of Cognitive Neuroscience at Kyoto University's new Center for the Evolutionary Origins of Human Behavior, EHUB. But he is a vertebrate paleontologist interested in mammalian diversity. He spent a lot of time studying and thinking about extinct carnivorans in North America, and so you might wonder what he's up to at a research institute dedicated to the study of primates, and we'll definitely touch on that in the podcast. Now, we actually discuss a pretty wide range of topics, from understanding biodiversity in an evolutionary context to help us contextualize biodiversity loss in the present and in the future, right through to exploring some of the amazing but sadly extinct species he's had the opportunity to study, like bear dogs, which we learn here is neither bear nor dog. We then get on the process of doing and communicating science and onto science education, as Susumu has long been involved in that through programs at museums he's worked at, like Chicago's famous Field Museum, and of course now, as we do together through CICASP. So it was such a treat for me to have and to be able to record this conversation, so I hope my enthusiasm for speaking with Susumu comes through, and that you all feel a little more nourished, as I did, coming away from this interview with Dr. Susumu Tomiya. I think I just want to get, starting maybe with a big picture kind of question,
Yes.
for you to get us started hot, which is, how do we typically use the past to understand the present and predict the future? And of course, asking you that question is very specific to kind of thinking about the history of life and what it is and where it's going. So why don't you get us started with something like that, really deep, philosophical, and also practical question?
Okay, that's a really big question. First, I think this is a two-step process. The first part is putting the present in the context of history. So, the former president of Germany, Richard von Weizsäcker, once said, anyone who closes their eyes to the past becomes blind to the present. And he was talking about the history of humans and human civilizations, but we can say the same thing about the history of life. And because we have a huge fossil record of millions of things that used to live on this planet, we know, for example, that mass extinctions have happened only 5 times over the last 500 million years or so. So it's a super rare event. And now we humans are beginning to cause another mass extinction. We wouldn't know that if we didn't have the fossil record, right? So putting things in context to raise alarms about what's happening today, especially at the hands of humans. So that's step number 1. And step number 2 is, like you said, trying to make use of the fossil record to predict what's going to happen in the future. So there are various approaches to this topic. One thing I've been working on is trying to better understand what kinds of animals, mammals specifically in my case, are more prone to extinction than others when environment changes. So I've investigated the relationship between things like body size and longevities of genera and species of mammals in the fossil record. Sometimes you see a negative relationship, but it's really dependent on the kind of environmental change that happens and at what spatial scale. Another project in my research has looked at co-evolution of major groups of mammals through time, and my colleagues and I found out that, for example, the body size evolution of rabbits and hares have been constrained by other groups of mammals, specifically ungulates, hoofed mammals, over many millions of years on continents. So having that knowledge helps us foresee big changes that may happen in the future if we lose these interactions among different groups of animals and also plants.
So I want to bookmark these because we'll come back a bit later to some of the specific studies about lagomorphs, for example, and about body size evolution.
Sure.
But just coming back to what you started with there, understanding the Earth's history of mass extinctions. So you were involved in a paper a large paper that has something like over 4,000 citations now from Nature, that was actually trying to confirm whether we are indeed living through a mass extinction. So just for anyone who might be curious, how are people thinking about defining mass extinctions in the past? And then how can we understand whether that process is happening now?
So if you look at the history of extinctions through time, there are these 5 peaks that stand out against the background. And basically, these are events in which at least 75% of species went out of business. They disappeared from the fossil record. So that's convenient definition for a mass extinction event.
And so from the history or the prehistory of it, we are dealing with information from the fossil record. But so how can we map that onto what's happening now then to understand?
Right. So what we did, and this paper you mentioned started out as a paper that was put together in a graduate seminar when I was in graduate school. But anyhow, we had not just paleontologists, but people who are studying living animals. And we looked at the IUCN Red List to compile the numbers of species of animals, mostly vertebrates, because they have the best fossil record, that have gone extinct over the last 500 years. That's a time period in which the human impact on various ecosystems everywhere on the planet has really intensified. And basically we compared both the magnitude and the speed at which these species have been lost over the last 500 years against the magnitudes and speeds at which species were lost in the deep past.
So this is something that's been interesting to me as well, and thinking about what the typical lifespan for a species actually is. I think, if I'm not wrong, it's somewhere like 1 million years or 10 million years, something like that, in between that range.
Yes.
And how do we get that information typically from the fossil record?
So if you're a paleontologist, you go out to the field and you find fossil remains of animals that used to be around. You extract them from rocks, right? And in the case of mammals, the typical longevity for a species is around 1 to 2 million years. And you can date sometimes the fossils themselves if they are not that old, but also the rock layers that contain these fossils. So by bracketing the first appearance of the fossil species and the last appearance of the fossil species, you get estimate of how long that species was around in that region. And that's going to be the minimum estimate because most animals are not preserved as fossils.
Right.
So there are various statistical techniques to take into account the imperfect sampling of fossils.
I guess that this is a process of improvement over time too, in how dating or how accurate dating can actually be, and but of course the Earth kind of shifts around in ways that are not always fully understood. So, what would be the current kind of error bars around that estimate of 1 million years for a species?
I'd say that's a fairly solid estimate.
Okay.
Yes. How much error bar is there really depends on the time and place when the species lived. Yeah. So you have to have datable rock layers to begin with. It's not always there in certain places. Yeah. On the other hand, there are certain places where you get the time resolution of thousands of years, really fine-scaled record of evolution and extinction of animals.
So one thing that seems to be really important then in this, asking the question of whether a sixth mass extinction is actually happening is understanding that kind of background extinction rate across species. And in papers that I've seen, the current rates are not even close to what you would predict based on those background kind of extinction rates. Again, with a lot of error bars, but even if you consider different scenarios of estimation, and there could be conservative estimates or, more liberal estimates. So how confident are we? And actually, if I'm not wrong, the background extinction rates over time have been decreasing slightly, or is it slightly increasing? I don't quite remember.
I think it depends on what groups of animals, plants you look at. Okay. And at what level of taxonomy you're looking at.
Right. So, that's another question I wanted to ask you, because I think you've also been involved in studies looking at, or you have led studies looking at, depending on what scale you're kind of measuring. And in this, we can go back to maybe the body size question, because you might look at species extinction rates. You might look at higher order taxonomic extinction rates, and there could be some differences, if I'm not mistaken.
Yes, there could be. So, for example, we group species into genera and genera into families and so on, these hierarchies of biological organization. A lot of that is imposed by us, so these are artificial concepts, but there are also these clusters of ways of living, so it's not all smooth gradation in nature. And so for this project, looking at the relationship between body size and extinction probability in fossil mammals, I was looking at the fossil record at the level of genera. That's one step above the species. And the practical reason for that was because it's often very difficult to identify specific fossils at the level of species. It's more feasible to do that at the genus level. And also the classification of species changes a lot over time as our knowledge of extinct animals improves. But also it's interesting to think about the ups and downs that these groups experience at fairly large scales of organization. So that's why I was interested in genus level patterns.
So why ask the question though? So I assume there's quite a lot of research on the predicted relationship or expected relationship between body size and probability of extinction or survival. So what is the main hypothesis being tested here?
So based on what we know about mammals living today, large mammals have been disproportionately at the risk of extinction. So I wanted to know whether that was the case in the past, looking at the fossil record. And it turns out in general, no large-bodied genera do not have shorter durations, longevities, than small-bodied genera. So what we are experiencing, at least at the species level, seems to be pretty unusual in the history of mammals.
So are we then kind of narrowing in on the reason for it might be much more related to human activities than in the recent past?
That's right. So most of the fossil record is outside of the period in which humans existed. So their extinctions had to be driven by non-human related environmental factors like climate change versus what's happening today. It's a lot of overhunting, destruction of habitats and so on. So the nature of the threats is really different today, and so that's probably reflected in the different patterns of who's at risk.
Right. I think recently I teach a conservation biology class in Kyoto University, and we were talking about how if you look at a macro level, the loss of so-called charismatic megafauna around the world is pretty biased to places that are more developed and historically have had more human expansion. Whereas in Africa, I think you still have a pretty large percentage of the original megafauna that still exists there, and that's pretty amazing, I think.
So you raise a good point about surviving megafauna of Africa, because other continents also did have megafaunas up until fairly recently, geologically speaking, so around 10,000 years ago or so. So we live in a world with very deep, impoverished mammalian faunas in terms of loss of large animals. And it's one of the big mysteries why large mammals manage to survive in Africa. There are some hypotheses, like animals were more used to humans because they had longer history of coexistence, so somehow they hit balance. But we don't know.
Yeah, but it's definitely, when you use the word impoverished, I might use the word just devastatingly sad that we can no longer go around and see things like giant sloths, and would be a really amazing place.
Saber-toothed cats.
Saber-toothed cats we might want to keep a bit of distance from. But actually maybe that's a good segue then into some of the work that you do. So you have mentioned that you've mostly focused on mammalian evolution, and I think you have a focus also in North America. So maybe I'll just ask a couple of random questions from things you've worked on, and then you can talk about them. The first one being, what are bear dogs, and what are we missing since not very many people know about them?
All right. So bear dogs are a group of carnivorans. So they are related to the living dogs, cats, bears. They are neither dogs nor bears, technically speaking, but related. And this group is entirely extinct, but they used to be pretty successful. So in the fossil record, if you go back in time by tens of millions of years, they are found on several continents, northern continents. And initially they were little critters like I'd say house cat-sized animals. That was about 40 million years ago. But then some of them evolved to humongous sizes. So bear-sized animals appeared in the Miocene, for example, and they were some of the top predators of the time. So in that sense, this is an ecologically really interesting group of mammals.
So you mentioned the Miocene. Maybe you can just date that for us specifically, and then also at the same time describe what the kind of biodiversity in North America would have looked like that surrounding the bear dog.
Right. So Miocene is from about 23 million years ago to about 6 million years ago. And this is, if you imagine a giant safari That's kind of what it looked like in the Miocene of North America, although there was a period when it was really warm and forests expanded. It's called mid-Miocene climatic optimum. But basically it was a wonderland for big, fierce-looking mammals. And that followed gradual cooling and drying of the climate coming from the previous Oligocene and Eocene before. So forests opened up, grasslands spread, horses became bigger, and we started to see things that run around pretty fast. So that's Miocene in North America.
And so what kind of caused the downfall of this group? And also, were bear dogs, were they specific or endemic to North America? Or did you find them throughout the world?
No, they are found on other continents as well. But they were never really super diverse. So in that sense, as a group, they had a higher probability of going extinct, I think. And also, as you become bigger, your population density tends to go down. So big animals in general have higher extinction probabilities. Although, if you look at mammals, so this is going back to my body size study. One of the interesting things that I haven't mentioned is that I said that the relationship body size and longevity of genera doesn't seem to be the general rule in the fossil record of North America, but there is an exception, and that's carnivorans, animals that eat meat. So among them, large-bodied genera tend to have shorter durations than smaller ones. So I think that has something to do with small population densities of big guys.
Right. So that because they're so dependent on a limited resource, it makes it harder for the top level, in the trophic pyramid to survive. I see. Yeah. And so is that pretty much what the downfall was then for the bear dog in North America? Just dwindling prey supplies? Yes.
Well, possibly, or changing types of prey, because toward the end of the Miocene, and the next time period is called Pliocene, but that's when you have strong aridification of the climate. So it became really dry. And generally, becoming really dry is not good for plants and animals that eat plants. So that may have had a lot of negative impact on the megafauna at the time. And we see many extinction of large herbivores like camels at that time. So that could have downstream impact on things like bear dogs.
So at the same time, there would have been other carnivores and top predators in the ecosystems. And I know you've done some work on wolves as well in North America. And maybe I'll just throw this question out. People might not understand it right away, but hopefully you can pick it up and tell me where I'm wrong and what to actually take out of it. But why do all the North American gray wolves look more or less the same wherever you find them, whereas in other places there's a lot more diversity depending on maybe it's the climate, local climates, or habitats?
Well, actually there is surprising amount of morphological diversity among North American wolves. And so I'm not sure how to answer your question, but
I think you were talking about ecomorphs in the gray wolves, and maybe less diversity in ecomorphs there, if I'm not mistaken.
Yes, right now we are losing a lot of morphological diversity within the species of gray wolves in North America. If you go back in time, again, we looked at the fossil record of gray wolves through time and space. A lot of them tended to have short legs for most of their history. Very recently, we started seeing this long-legged morphotype in North America. And at the same time, the short-legged subspecies that's known as Mexican wolves, they have been almost exterminated as a subspecies. So in that sense, there's been a big shift in what North American gray wolves look like over the last probably a few hundred years.
Mm-hmm. So this is based on, or what would be driving, you're looking at leg length specifically in these studies, but what would be driving then the ecological or climate factors that would drive variation in leg length and similar traits?
Right. So my colleague Julie Meechan at Des Moines University in Iowa, and I have thought about this, and a working hypothesis is that it may have something to do with change in the prey species of the gray wolves. So for much of their history, being short-legged was fine for them, apparently. And from historical records, we know that a lot of the gray wolves hunted on things like bison, which was super abundant in North America until the turn of the 19th century. But at that time, bison and the gray wolf become subjects of basically extermination in North America. They were overhunted. And so the gray wolves lose the prey base, and then they would have to switch to other kinds of animals for food. So we are potentially talking about fewer prey animals, or smaller animals that run faster than bison. And in either case, you'd expect gray wolves that have longer legs and are more efficient at covering longer distance in search of food to have some advantage in surviving. So that's our working hypothesis
I see.
at the moment.
Is there any relation to thermal regulation as well in this context? So you see some maybe general patterns as well in morphology or in body shape based on what the climate is doing.
Right. Yeah, so we've thought about that. For example, in places where you get more snowfall, it may be advantageous to have longer legs. But like I said, for much of the history in North America, gray wolves had short legs, and that's true whether you go to Alaska or Southern California, and across tens of thousands of years during which we had cycles of glacial periods and interglacial periods. So climate doesn't seem to have huge impact on the leg length in North American gray wolves, at least. Okay.
So I think one theme that's coming out, and I want to bring this back to the extinction question we started with, is that, and this is, anybody who's studied any bit of evolution will fully understand already, is that there's so much contingency. And the interactions that species have with each other become so important in their longevity and what's going on. And so you mentioned earlier that you looked at rabbits and hares, and I love the title of the paper that you wrote about that. Why aren't they bigger, or why aren't they larger, basically? So maybe you can talk about that a little bit. You mentioned earlier it was because maybe body size is being suppressed by some of the larger herbivores that already exist in the ecosystem.
Right. So rabbits and hares are extremely successful group of mammals today. They are found on all continents other than Antarctica, and they can be super abundant locally. And yet their species diversity is so much more limited compared to things like rodents, which are the sister group to rabbits and hares, and also compared to ungulates, even-toed ungulates, also known as artiodactyls. So why is that? Also, in terms of the body forms and body sizes, rabbits and hares are very limited compared to these other groups of mammals. So we looked at the patterns of body size distribution across space today and also across time in the fossil record to try to answer that question. And there are several independent lines of evidence suggesting that the body size evolution of rabbits and hares have been constrained by other plant-eating mammals like ungulates. So one of the pieces of evidence was that if you look at the relationship between the body size of largest rabbits and hares and the smallest ungulates in ecoregions today, there's a pretty tight link between those two variables. And then across time in the fossil record going back to about 43 million years ago, again there's really tight link between the trajectory of the largest rabbit and hare body size and the smallest ungulate body size through time. So they are going up and down together in parallel.
What is, if I can interrupt, what would be the largest fossil rabbit or hare? Or now are they pretty large?
Yeah, so they can be up to about 5 kilos on average. And actually they've never really exceeded that limit over the last 43 million years on continents. However, if you go to places like Mediterranean islands, there are extinct rabbits that weighed probably close to 8-9 kilos, so substantially larger than the largest living lagomorphs. And as you know, on islands, you have very different kinds of dynamics going on because you have a lot fewer species living there, fewer competitors typically. So that may have something to do with why they could become so large on those really special environments.
It is fascinating. I mean, the other, the flip side of that coin is the concept of island dwarfism as well. So you can have radically different trajectories depending on the conditions of an individual species and island.
Yep. Big animals tend to become really small on islands. Small animals tend to become much bigger on islands. Yeah, that's been one of the major unsolved mysteries of biology.
It's good to know we still have questions to ask. I'm interested to know whether you have a thought on this or an idea on this, but if we think of the history of mammals, it seems like, and maybe this is why you posed the question originally, but it seems like most major groups do have pretty huge size variations over their evolutionary history, and that can range, from tiny, a few hundred grams to, really, really many kilograms or tens of kilograms. But the groups that have not probably experienced so much size variation, I mean, some would be obvious. You could look to bats as an example. I mean, within bats, there's some pretty big range in body size because they get down to just a few grams. And then you have these giant fruit bats. But you're not likely to find a multi-kilogram bat flying around the sky. And obviously flight is a big issue with that one. But what other, and then apart from rabbits and hares, are there any other kind of groups of mammals that also haven't experienced similar size variation over their history?
That's a great question. Well, rabbits and hares really stand out as having a very restricted body size and body form diversity.
Before you started looking at that, though, was that an open question? Was it something that people were interested in? Because I feel like it's one of those that kind of come out of left field, but obviously I'm not a paleontologist.
I think it did kind of come out of the left field because most evolutionary biologists, are fascinated by super diverse groups of animals, whereas I was focusing on a group that was lacking in diversity. Just looking at the flip side of the coin. But thinking about groups with limited body size variation, things like marine mammals, they have certain constraints on the lower limit of their body size, so they can't be super small.
Right.
You don't have mouse-sized sea otters or whales, right? That's for thermoregulation. So that would be another example. You mentioned bats. Yeah, that's also, well, in that case, you have a biomechanical constraint on how big you can become. Yes, but otherwise, most major groups of mammals have really diversified, and that's why we call them major groups, I suppose.
So maybe I'll ask you a process question then. It's kind of on the personal side, but like, how do you approach developing ideas and questions to ask from the kind of data that you know how to collect and analyze? What is your process there? Because it seems like you've generally focused on evolution of mammals and diversity and macroecology, but yeah, how do you devise your research programs and questions, and where do they come from, and what guides you?
So fundamentally, I'm really interested in how the diversity of mammals is generated or maintained or lost over time, and to figure out the mechanisms behind these processes. You really need to be studying not just the fossil record, but the patterns we see among living species of mammals. And so I tried to be both in paleontology and what people call neontology, or the study of living organisms. And like you said, macroecology is one of the important areas for my research, because it's looking at ecological patterns at really big scales. Paleontology is great at answering questions at really big scales. So that's where you see matching scales between different disciplines. And yeah, so I try to draw ideas from different fields of ecology and evolution to design my studies.
Okay. I'm going to come back to this probably towards the end of the interview, but a few years ago, you find yourself among primatologists at an institute in Kyoto University, the formerly known as the Primate Research Institute. And obviously you still work and publish in mammalian evolution, but how was that transition to being at an institute that focuses on a group of animals that is quite distinct from the ones you focused on in the past?
Right. Well, I mean, at the end of the day, primates are mammals.
Sure.
So they do fall within that category. But yeah, it's been really fascinating experience working here and learning about primates. And especially being based at Indiana, I get to learn about all aspects of primates. And right now I have an ongoing project looking at variations in the shapes and forms of milk teeth in primates using the collections on Inuyama campus.
Can you describe what milk teeth
are? So like as humans, most mammals have two generations of teeth. First, they have a set of baby teeth, also known as milk teeth. We shed them. They are replaced by adult teeth. So we have two generations of teeth, and I'm interested in how their shapes are related between those two generations and also across different species among primates. And this is because teeth are super important if you're studying extinct animals. Much of the fossil record of mammals is made up of bits of jaws and teeth. So if you want to understand the history, you need to understand teeth.
Yeah. I remember being, as an undergraduate in the University of Calgary, we had a collection of casts. And I think one of my projects in one of my classes was about Antillean primates living in the Caribbean. And yeah, so I spent quite a bit of time measuring those. But I guess this is really important in a way, in a methodological sense, so that you maybe can interpret better the data that you get when you're looking at these teeth. Is that correct?
Yes, that's right. So for example, you use shapes of bones and teeth to reconstruct the evolutionary relationships of extinct species. And baby teeth may contain useful information for that purpose.
So I also am kind of curious if you, since being here, if you have been surprised at all, or have you considered maybe some of the major differences and similarities that you hadn't considered before when including primates into your own concept of mammalian evolution?
Well, what's nice about primates is that their ecology has been really well studied, whereas a lot of other mammalian groups, there's so much we still don't know about basic things like what they eat. And so in that sense, primates are a really convenient study group for studying evolution.
Yeah, and I think, so you have also spent a fair amount of time in museums in your history, and including some pretty well-known ones like Chicago's Field Museum, which I think you're still associated with to some degree. So I'm kind of curious, and maybe we'll get into the kind of dual, I don't know exactly how to say it, but working in collections, working in the field, which I guess you're familiar with both of them. But do you have some specific feeling when you walk into museums of that sort?
Yes.
Something that really inspires you?
Sure. I feel like I'm a creature of museums. I spent so much time when I was a graduate student and then as a postdoctoral researcher in museum collections. So I could say I practically lived in collections. And natural history collections are hugely important sources of information for understanding the biological world.
So can you describe what working in a collection is like from your own experience?
Working in a collection is enormously gratifying because, you are exposed to millions of specimens which only a few people can access. Well, the collections are open to legitimate researchers, of course, but they are generally not open to the public. There's just not enough space to exhibit all the specimens. And you often find new things just by opening drawers in cabinets. So that's really the excitement of collections-based research.
I mean, I there's always stories of, some new species was discovered from a collection where it had been collected 100 years ago or something and just sat there in a dusty shelf. But I feel there's something overwhelming as well about that. You're in a room with all of this prehistory, and I mean, even cataloging for people who manage collections must be a huge challenge.
Yes, so you definitely feel the weight of the history of life when you are working in a collection. And yeah, for big museums, typically big museums have not nearly enough staff members to take care of collections, so that's a perennial issue. But when I was working at the Field Museum, we had an excellent group of not just researchers, but collection staff and college student interns who work together to process specimens for the museum. So cataloging fossils, identifying them, putting them in nice archival boxes and trays and so on. So we took care of thousands of specimens, and it's definitely a lot of work that tends to be underappreciated because it's not super visible to the public.
Right.
It's not the most glamorous part of paleontology or zoology, but super important.
So how, I mean, within a collection, of course, there may be things that are left for later to discover new information from, but how does a place like the Field Museum, and maybe that's not the best example because itself is already quite famous in this landscape, but how would a collection manager or an institution that has a collection promote it in a way to attract researchers to do work and increase the value of that collection? Because a lot of work has got into it, putting it together and keeping it for some purpose, which is not always clear right away, especially to people funding things like that. But so how does that happen?
So in recent years, there has been a big push to digitize collections at many major natural history museums. So taking really good pictures of specimens or 3D scanning them and putting them on the internet, making them available to anyone in the world. So I think that will help open up collections to more researchers. And otherwise, it's often visiting graduate student scientists and people like retired professors who have enough time to browse through collections to look at specimens.
That's fascinating. I myself have very little experience. I know that we have a collection of fossil primate or casts, and also a big collection of bones from the kind of historical study around Japan. So what is your impression of the collection here? And I guess you're using it for studies of milk teeth?
Yes, not just using, but I also take care of the collections of non-primate vertebrate osteological specimens, so bones of dead animals, basically. We have a lot of, for example, tanukis, raccoon dogs, about 400 specimens now, with my colleagues here on Inuyama campus. And so we make specimens from dead animals, we catalog them, and we preserve them in the collections. I think our collection is actually one of the major osteological collections inside Japan.
Wow.
Yes. And all the information in terms of what we have in the collections is open to the public. There's a searchable database online. So we are really hoping to attract more people come here and use them for research. Not just research, but also for educational activities. So I go out to this university in Aichi Prefecture once every year to give guest lecture to students who are ceramics majors.
Oh, wow.
So this is an art school, basically. And these people are really interested in the shapes of natural objects like bones. So I talk about mammalian bone morphology, and they get inspirations about their creative projects. So things like that.
Yeah, that's really exciting. I mean, I feel like when you have a collection, that's one obvious way to use it, is to engage with the public from different types of audiences. And I know that you've been involved with various educational programs through your experience at museums. So can you maybe talk about that too? Is it something that you were always interested yourself in, was being able to share this kind of natural history knowledge, or is it directly because of your work at museums that you were exposed to these kind of educational programs? Or because I think the education is something that's quite important to you.
Right. I guess I started being involved in educational outreach programs back in graduate school. There was a strong push to communicate the science of paleontology to the local communities when I was a graduate student. So we had a lot of events where we put out fossils on the table and interacted with members of the public. That was always super fun. And then at the Field Museum, one of the most rewarding things about my job was looking at these school children coming to the museum and getting super excited by the exhibits. And there are also a bunch of student interns, and I put out fossils for outreach activities, and it's just really encouraging to see regular people get excited about the science you do.
Yeah.
So there's a real joy in that process. And also, paleontology, a lot of people think it's all about digging up dinosaurs and assembling skeletons to exhibit them in museums, but we do a lot more than that. So paleontology can be a good gateway for talking about the current biodiversity crisis, for example. So those, I think, are really missions for many of us who work in this field.
I'm glad you brought that up, because people can think of major institutions where they can go and learn about life. Museums is certainly one of those, and places like zoos is another example of it, kind of in a different way, obviously, exhibiting the living and then exhibiting the dead. But one of the challenges that zoos has is the understanding whether what they're trying to communicate is being received, by the visitors. A lot of people think going to the zoo is a great day out with your family, and you can have this nice time, but it's not necessarily about education. Although zoos now have revamped their missions in the last, say, century or over the last century to include, providing information and education about biodiversity, about conservation, more recently about animal welfare, things like that. But it's a constant struggle to know whether those educational activities are actually valid or effective. Right, and so that's something that's been plaguing the world as well. And I'm wondering maybe if you can talk about that kind of situation in museums. I mean, on the face of it, it seems like museums are much more geared around educating people about things, and it's not only about life, but it could be museums of art and things like that. But what's your perspective on that? Do museums do a good job currently, and in what ways? And in what ways can they potentially improve their educational capacity, especially if, as you just mentioned, they can also be a place to educate people about biodiversity, and the ultimate aim of that is to make them care about the natural world and protect it.
Right. So that's a really good question. It's easy enough to do these questionnaire type surveys with museum visitors to try to gauge what they got out of their experiences of visiting places like museums or zoos. But really, we need to be thinking about the effects these institutions have on people over a much longer time span.
Mm-hmm.
When these kids become adults, have we made any impact on them in terms of taking actions against climate change or biodiversity crisis? I don't think we have a great way of predicting it or measuring it right now, but it's definitely a major challenges for natural history institutions.
Yeah, I can't really think of any kind of cohort studies that started with kids at a young age visiting a specific exhibit or a specific museum or zoo, because you have those for medicine or for psychology or for various purposes. And obviously it might even take multi-generations of scientists studying that cohort over time, but it would be interesting to know if there's any going on for this, preparing people for the future of biodiversity and our stewardship of nature.
Yeah, I'm afraid the typical research funding cycle is too short for something like that, but there's definitely need for that. And the other thing that institutions can do is not just to receive visitors, but to go out to the community and go visit places like public schools, bring their collections to classrooms where serious scientific subjects are being discussed, as opposed to people just hanging out to have fun for entertainment. So that's the real outreach, right? So I think a lot of us should be making more effort in that direction, getting out of our little comfortable buildings.
You could call them ivory towers, I suppose.
We
sometimes.
could, yeah.
So in all this talk about education, and did you have mentors? Were mentors important for you in kind of shaping who you've become as a scientist and an educator? Does anything jump out for you?
Yeah, I have a number of mentors. I think I have to thank my father, first of all, because so growing up I was really into insects, catching butterflies and dragonflies in my neighborhood in a city called Kuwana in Mie Prefecture, not too far from here in Myanmar. And that's how I really got interested in the diversity of life. And then in college...
If I can just interrupt, I feel
sure.
like in Japan, so many kids are just fascinated by insects, and including my own, especially my son.
Yeah.
But I find it a little different because growing up in Canada, I don't think that people were that interested in general. Certainly no one among my friend group was interested in insects. They might go around using a magnifying glass to burn an ant or something on a sunny day. But apart from that, I can't recall anyone in my group who had an insect as a pet, for example, who kept them. And so what's going on here?
I think it's a nice tradition here. Although even when I was growing up, a lot of kids are more into playing video games than catching insects. So it may be sort of going down. I hope not. I'm glad your kids are still interested in bugs.
When we take the headlights out in the backyard at nighttime in the summertime, it can be pretty fun. So yeah, they're definitely still around. Yeah,
and I don't know so much about Canada, but there's just so many bugs around here.
Japan is a buggy place.
Yes. And also, at least traditionally, parents encourage their kids to just go out and play outside of houses. And you just see butterflies, grasshoppers, cicadas. There are millions of them around. So naturally, kids are attracted to these things, I think. So that's how I got hooked, I guess, and became interested in the diversity of life. And then in college, I had opportunity to take a graduate seminar on mammalian evolution, which was taught by Ken Rose. He's expert on mammals that are 50 to 60 million years old. And I was really fascinated by the history of mammals. So that's how I decided to pursue my academic career. And in graduate school, so up to that point, my interest was in fairly classic mammalian paleontology. But going to graduate school gave me a new direction, in the sense that my advisor, Tony Barnowski, was someone who was really at the forefront of cultivating this new subdiscipline of conservation paleobiology, learning from the fossil record to understand what's going on to today's biodiversity and how we can protect it for the future. So that's where I got this sort of a integrative approach to science. Yeah, it definitely comes out. And I find that last part you mentioned quite interesting. I'm not sure. There's probably a certain public perception of what a paleontologist is, and you alluded to it earlier, somebody who puts together skeletons or fossils for collection or for display in museums. But it seems like there is a movement now to involve paleontology in, and that's probably why I started the interview the way I did, in what's going on now. And I think that's a really good perspective to have. I mean, anytime, I think as science progresses, usually people think that it's the merger of disciplines that lead to the best discoveries. And so I'm looking forward to what continues to come out of that field. But so we talked about museums, but you've also done some things in the field. And so you said you're a creature of museums, but what about a creature of the field? What are your experiences there, and how do you feel about doing fieldwork versus working in collections? Right. So we talked a little bit about this project looking at gray wolves in North America. So related to that study, when I was a postdoctoral researcher, my postdoctoral advisor, Julie Meachen, at Des Moines University in the state of Iowa in the US, and her team, we all went to this really cool cave in northern Wyoming. It's a vertical cave that's about 25 meters deep. We went down into this cave, and there are thousands of bones of Ice Age mammals at the bottom of this cave. So we collected these fossils, and that was probably my most fun field experience to date.
I think you have photos up on your website of you rappelling down into this.
Yes.
So how deep is this from the surface?
Oh, so about 25 meters.
Okay.
Yeah. You have to basically rappel down, and once you are down there, it's cold, even when it's grilling hot outside. Inside of the cave is like inside of a refrigerator.
Wow.
So that's supposedly good for preserving the original organic materials of these bones. And so we've been studying not just the shapes of the bones and teeth, but some of our colleagues they've extracted ancient DNA out of these fossils and used them to reconstruct the population histories of different species of large mammals since the last interglacial period.
So, kind of returning to this perception question, but I think there's a lot of romanticism on both sides about discovering new fossils, for example, or building something for display in a great museum, and then there's this idea of what the person doing it is kind of like. So I think we've talked about this before, and you've presented about this before, but what are the kind of common misperceptions or misconceptions about what a paleontologist is, that I don't know if it ever irked you, or just things that you confront, and then what would people be surprised about to learn that something about what you do?
Right, so there are a lot of misconceptions about paleontology, and the romanticism that you mentioned, it can be good. People call paleontology gateway drug to science. So it can be good, but at the same time, not all of us are looking for dinosaurs. Actually, most of us are not looking for dinosaurs. And also, the time we get to spend out in the field collecting specimens is a pretty small part of our professional activities. Unfortunately, I wish if I could spend more time out there, but the reality of being an academic is, you have to teach classes and, like I said, take care of collections and things like that. And another, I think, misconception nowadays is that I think people have very masculine image of paleontology.
I see.
So if you look back at movies like Jurassic Park series, the major characters were all males. Well, there was this female graduate student who was a paleobotanist. But anyhow,
I recently reread Jurassic Park, the original novel by Michael Crichton, many years after reading it the first time, before the first movie came out. And in 1993 or 4, whenever it was that the movie came out, and the book was shortly before that, I didn't really notice it. But in the movie, the character you just mentioned, the paleobotanist, Dr. Sattler, I think is her name.
Yes.
She actually has a pretty good role in the movie. Maybe it's not quite as in your face as some of the other characters, but she in my opinion, comes across pretty well. But rereading the book, Michael Crichton did her a very bad disservice. She has a tiny role in the book, and really just kind of a cliche character that doesn't have any influence on the plot. Whereas I found in the film, she actually gets a little bit more recognition. So that was one case that I don't know, maybe it happens a lot when you re-look at some piece of, whether it's literature or go back to old movies or something, you can get a very different perspective as the times themselves change, of course.
That's interesting. Yeah. And but we have a lot of really hardworking and talented women and LGBTQ people working as paleontologists these days. So the field is a lot more diverse than many people in the public realize.
Yeah, that's really interesting. It I guess that's kind of a good segue to think about how the last few years have gone for you too, because you joined the Center for International Collaboration in Advanced Studies in Primatology here, previously at the Primate Research Institute. And we continue. We've been working together for that whole time. And one of our major missions is kind of outreach and education. And I suppose we try and do that in a way that's inclusive. Our graduate group obviously is, in some sense, it's narrow because it's people who are all interested in this really esoteric thing of primatology and wildlife science. But it also includes people from all over the world. And so what has been your impression of joining this program and being an educator within our graduate program?
So one of the things that pleasantly surprised me when I joined Primate Research Institute back then was how diverse the community of international students and scholars was on this Inuyama campus. You can meet people from all over the world just being at the PRI. And so it gives us an incredible opportunity to have cross-cultural conversations about the best ways of internationalizing science. And we tend to conflate internationalization with westernization oftentimes, but we have a lot of people from non-Western countries, and I think this is that gives us a great opportunity to think about more inclusive ways of moving forward in terms of diversifying the community of scientists and reaching out to communities of non-scientists as well.
Yeah, and I feel like you mentioned earlier about getting out into communities. I mean, I think one of the most important points of having a strong international community here is that each one of them will, I mean, maybe not directly, but will eventually be able to influence people around them where they come from, and maybe even more broadly than that. So I agree, it's a great opportunity to have people, and sometimes sometimes stimulate or creating environments that are stimulating to everyone equally and allow everyone to have a voice can be pretty challenging, though.
Yes. But I think in the last few years, we've had a lot of success in encouraging our graduate students to be more engaged in science communication, not just professionally, but directed to the public.
That's right, yeah.
So we had, some of the graduate students gave award-winning short talks and things like that. So I'm really proud of them.
Yeah, mutually so. It's a nice, I mean, it's great for us to be able to say we have students that are that bright and take that kind of initiative. But I think it also is a testament to the fact that we're trying to encourage people to do that in any kind of way. And it's something that's really important to us here too.
Yeah. I think it's really important to really make an effort to push science communication and public outreach, because otherwise all of us are under heavy pressure to publish papers. So it's easy to forget these other responsibilities of scientists, I think.
So on that, so one thing you haven't mentioned, but you talked earlier about having mentors as an undergrad and a grad student. So you went to school in the States, you were an undergrad at Johns Hopkins and then a grad student at UC Berkeley, and but you grew up in Japan to a point, and now you're back in Japan. So you kind of are in a unique position to see this, whether it's things like how paleontology is done or how science is done and how it's communicated in two very different cultural communities. And so can you talk a little bit about that? I mean, what were you, maybe, I guess you went to the States at a pretty young age. You must have been in high school, if I'm not mistaken.
I was.
So you might not have like the most formulated version of what it would have been like in Japan at the time. But what were the kind of things that you thought were different as a student in the US, as an undergrad and a grad student? And then on the flip side, what do you kind of not necessarily struggle with, but what do you find surprising in this same sphere, having come back to Japan now? Not to put you on the spot with a rather challenging question.
Yeah. So, well, I think one major difference that I was surprised by is the opportunities for teaching as graduate students was quite abundant in the United States. Obviously, you don't want to spend too much time working as a TA, but I spent practically half of my graduate school teaching classes,
Wow.
undergraduate biology courses for the most part. And that really cultivated my love of teaching. And also, it's really a craft, so that was a fantastic opportunity. And here I wish if more graduate students on Inuyama campus had similar experiences. Maybe not as much as me. I could have used a little more research time, but so we try to work with a few teaching assistants every year at SciCast. But so that's one major difference.
I definitely concur. I mean, I did my PhD or doctoral studies here in Inuyama, and I was really looking for opportunities to teach and get engaged, be a TA, and not necessarily in the way that's possible around here, where you might be a tech person who sets up, projectors or computer stations for a certain lecture that you have nothing to do with, but actually being involved in a course, as I was as a master's student in Canada, but it was hard. And even here in Inuyama, like, it's a graduate institution, so we don't have undergrads here, so there's the professors themselves are not teaching that much. But once I flipped that side and became a lecturer at Kyoto University, I've almost always given opportunities to grad students to become a TA, and usually I'll hire somebody with funding from the university as a TA for my courses, and for postdocs and things. I always offer guest lectures in my classes within the theme of what we're discussing. But yeah, this was a big thing for me too that I felt was really lacking in that part of my education. So I'm really happy to be able to share that wherever possible.
Yes. Otherwise, let's see. So, I think I was also surprised by how international Kyoto University was. So in that sense, things were not that different back in the US and here in Japan.
It makes me wonder though, because originally people have this impression that Japan isn't as diverse as many other places, and that's true in terms of the population. It's a very small percentage of it, which is immigrants or of non-Japanese origin. But actually here at Kyoto University, at our institution in Inuyama campus and our sister at the Wildlife Research Center in Kyoto, I think more than 30%, close to 40% of our student body is international now. And that's changed a lot over the past 10 years, especially with places like SciCasp really helping, providing a gateway, an entrance exam in English for people to come. But if I think back to my own grad experiences in Canada, my cohort was far less diverse. So by and large, most of us are Canadian. And of course, in Canada, you have a lot of different backgrounds of people as well, and different ethnicities, which is just a natural part of the culture and the community. But there were much fewer international students in our program. It is, of course, smaller. So here we have many departments and many faculty members that can take students. But I just think it feels a little more diverse here even. And I don't know if that's your experience in the States where you were at UC Berkeley, for example. But I'm always pleasantly surprised in our community anyways at how diverse it is.
Yes. And one interesting difference, I guess, is that, yes, we did have a lot of international students at my graduate institution in the US. But a lot of people who come to study in the US, they obviously try to integrate themselves to the American society and culture. So, for example, the way people speak, even when they are not native speakers, they try to imitate the way people speaking the US.
Mm-hmm.
Whereas here you hear a lot more variations of English, for example, and that's really interesting, and it made me think about how we should be teaching science communication, for example. So I think the way forward is becoming more inclusive in terms of how people speak. For example, we shouldn't be pushing too much to standardize English language communication, and instead get more used to hearing different varieties of English being spoken. So yeah, I've not have thought about things like that had I not come here to India.
Yeah, that's interesting part of a much bigger discussion now, and even including publishing in science or other academic circles. I know recently I noticed some journals have begun accepting abstracts in multiple languages, so you could write an abstract in English, of course, for the international community, but include an abstract in your own native tongue, which is a really nice touch, I think. If not the whole paper, at least you have a summary for people in the native language. But there's also the flip side of that, where a lot of times, and we help a lot of international students and Japanese students with their English in manuscripts, for example, and it can be quite trying because it's a huge handicap, obviously, to publish in English when that's not your first language. And reviewers can be pretty harsh, and editors can be pretty harsh on language. So a lot of times people are left with either finding good colleagues that can spend a lot of time with them to help with the English, or paying for professional translations, which are done by people who are not specialists in their field. And so it can often lead to different kinds of problems. But do you have any thoughts about this? I mean, something I've been thinking about more and more too is what kind of a standard do we need in an international scientific community? Things need to be understood and specific, especially if they're technical. But I don't think the technical terms are what non-native speakers struggle with. Because if they're in a field, they're specialists in a field, they know the technical language. It's more the putting it together in a narrative, in prose, that challenges them. So it's something maybe I haven't thought that much about, but more recently, what do you think about that? I mean, should we really be trying to upkeep a certain standard of English in all of our scientific publications?
Yeah, that's a great question. I think we need linguists here to have that discussion. But to some extent, I think the kind of editorial culture at journal offices needs to change to be more accommodating. Obviously, whatever people write needs to be intelligible.
Of course.
And I've reviewed papers that were written by non-native speakers, writers of English, and sometimes I had great difficulty understanding what people are trying to say, and not because there were grammatical issues, but often it had to do with word choice.
Structure is a big one too.
Yes.
Logic.
Yes. So there's that. Definitely, we do need to have some standards, but I think academia can be a little more open to linguistic diversity, I think. Yeah.
Maybe one of the big problems as more and more people get access to even being able to conduct some kinds of research from around the world, I think it's really opening up in a really good way. And I don't think this kind of problem will get easier over time, but we'll have to get creative, I think, and find new ways to really make that as inclusive as we can.
Yeah.
To give everyone a voice.
I mean, I was recently listening to this podcast, and there was discussion about teaching English to non-native speakers, and apparently there's this research showing that when a bunch of people, none of whom is a native English speaker, communicate in English, things work better than when a native speaker joins that group in terms of things like business communication.
Right.
So that's something to think about.
Yeah. So maybe like the large herbivores and lagomorphs, there seems to be some kind of contingency that happens to people when there's someone with that's more specialized to something.
Yes.
Makes it harder for the rest to grow.
Yes.
Let's leave that as food for thought. So just to kind of get towards the end of this interview, I know that you, just briefly continuing on the topic of education and outreach, I know that you've been involved in some publications of looking at how we can improve the use of, whether it's collections or field sites or whatever, to engage the public, or, so how did, that's obviously a transition. It's something you've been involved with for a long time, but the actual writing and publishing, is that something that you're going to continue to try and do and work on, and maybe works towards to be a bigger voice in that sphere?
Yes, I hope so. So before I joined the Primate Research Institute, I was working as a postdoctoral researcher in Iowa, and there we had this after-school program for high school students from local schools, and we basically had these hands-on lab activities teaching them about vertebrate morphology and paleontology, and we supervised their individual research projects. And you'd be amazed at how much high school students are capable of doing in terms of conducting scientific research. Mm-hmm. Anyway, so we reported on that after-school program recently. And I think it's important to document these efforts in education-focused journals as a means of sharing knowledge and ideas with other scientists who may be thinking about engaging in public outreach programs themselves.
That's great. So just to close up then, what are you mentioned that you're working on various things, including this milk teeth project, but are there any other big projects that you're ongoing that we haven't talked about, or that you're hoping to start in the near future?
So this is much more of a long-term study, informal program, but there are number of really important Miocene fossil localities in the vicinity of Inuyama along Kiso River. These places that have yielded something like 19 million year old fossils of plants, mollusks, fish, rhinos, and I've visited these places with a number of graduate students from Inuyama to look for fossils, and we are getting better at finding fossils. It's been really fun, and so trying to build collection of fossils from this area is something I'm really interested in pushing.
So my last question then, and I just thought of it as you were talking about that, but since you're a paleontologist, and I know you've worked maybe mostly in Miocene collections, but if you were to pick the faunal diversity of a specific time period in Earth's history as being the most fascinating, which would it be and why?
Well, so my expertise is in the period of Eocene, or the epoch of Eocene, from about 35 to 55 million years ago. And this is when you see the ancestors of dogs and cats before they diverged into different lineages. And I'm fascinated by their evolution in places like North America as the climate change was taking place and landscape was changing. And these are groups of animals that few other people who are alive today are studying actively. So Eocene of North America with little dog cat ancestors is my favorite place to work in.
So for anyone listening with dogs and cats, maybe you found the place that you need to start looking for the origin stories.
Right.
Dr. Susumu Tomiya, thank you so much for being on the PrimateCast.
Thanks for having me.
You've been listening to the PrimateCast, a podcast series dedicated to all things primatology and wildlife science, to the conservation of species, and to the sharing of scientific knowledge. The podcast is hosted and produced by Andrew McIntosh, with artwork from Chris Martin and music from Andre Gonçalves. It is brought to you by the Center for International Collaboration and Advanced Studies in Primatology at Kyoto University's Center for the Evolutionary Origins of Human Behavior. Visit us online at theprimatecast.com and follow our social media feeds on Facebook and Twitter at The PrimateCast. Drop us a line anytime to say hello, to tell us what you think about the show, and to suggest future guests for the podcast.